Hey, good morning all. This is Ram. I'm the DevOps trainer. So before starting our demo, I just wanted to let you know my profile. So I'm having almost 13 years of experience in IT industry, and out of 13 years, almost 7.5 years, I'm having experience on DevOps and 4.5 years of experience on cloud technologies. And I'm working as a architect in one of the MNC in Hyderabad. Okay, so coming to my teaching experience, I'm having almost 5 years of experience while giving this training programs on DevOps as well as cloud technologies. Okay, so now we'll start with the DevOps. So what exactly the DevOps here? See, most of us we are an impression that DevOps is nothing but it is a technology. So with the help of this, we can able to automate the process. But as per as per the the requirement, see as per the standards. So DevOps is not a a technology. Actually, it is a it is a culture. So with the help of you can say that development plus operations. So it is nothing but actually altogether we can call it as a DevOps. It's a culture. So it is not a technology, it's a culture, or we can say that it is a process. So the point is here, if you go a little bit go back, let's say for example, 4.5 years back. So whenever if you want to deploy any services or if you want to deploy your code from development environment to the next environment, like a test environment or stage of performance or production. So what we used to do, so we used to prepare one CR, that is nothing but a change request. So in this change request, we used to prepare the different tasks, change tasks. So we used to assign these change tasks to different teams. So let's say for example, one task is to DevOps, development, and one task is to testing team and database team, etc. And as I said, once you create this CR, so we are going to schedule this CR for one particular day. And during that particular CR window, all the members should include and they need to complete their task successfully. So here one the issue is, let's say for example, the release management team, they started this CR window and thus they are asking team by team, they're asking saying that okay, testing team, so please complete your testing, database team, please complete your what you call the task, etc. Simple example, the release management team, they deployed the code from the stage environment, development to stage environment. So after that, what is the next step? Make sure that we need to test the code. Once the deployment is done, make sure that you need to test it. Make sure that you need to test it. Then only we can say that, okay, the application is working fine in stage environment. So this is the testing team responsibility to provide the a response and to provide the total a testing evidence to the release management team. Then only the team can, then only the team will consider that the CR is completed. Just one, so one point here. Let's say, for example, the testing team identified some bug in the features. Let's say in the login page, actually they are unable to use one option effectively. So in this scenario, what they are going to do, they are going to raise one defect, and they are going to assign that defect to the development team, and make sure that the development team should work on that particular defect and they should complete the what do you call, they need to resolve that particular issue. Again, they need to submit the issue in they need to submit that particular task in the next release. This is their responsibility. So here the point is, for a single environment, we are spending almost 1 or 2 days. So as I said in the previous step, actually there is a development issue. So make sure that the development team needs to complete their activity, needs to fix that particular issue, and then they need to resubmit the CR. So it will take 2 to 3 days of time. Let's say, for example, second scenario is during the CR window, the testing team is not available. So make sure that the release management team should wait until they receive the evidence from the testing team members. Then only they will close this CR. So here in this scenario also, we are waiting for the testing team members. So again here also we are spending almost 2 to 3 days of time. So ultimately, it will impact on the final product. Final product means like production delivery is impacting here. So to avoid all these scenarios, the companies actually they started implementing this DevOps culture. So in this scenario, as a DevOps engineer, we are the bridge. We are acting like a bridge between the development team as well as the other team members, other teams like development, testing, database team, business teams. Okay, we are like acting like a bridge between the multiple teams, right? And here, as I said, with the help of this DevOps culture, we are trying to automate the process. So again, under this DevOps culture, we are using different types of tools. Okay, we are using different types of tools. Okay, so what are the tools? We'll discuss one by one. Simple example is, I think people are most of us actually we are aware of this. Right now we are working on the sprint based like releases. So each and I mean every company is actually they are maintaining the scrum teams, and they are following the agile process, and they are make sure that the business teams actually they are expecting the new code in every 14 days. So in every 14 days, actually, they are expecting the new code in the production. So in this scenario, if you go with the old process, that is nothing but a manual, like a deployment process. Okay, it will not work. So that's the reason. Here, what we are doing, we are trying to automate the entire process. We are trying to automate the entire process. So for this, we are using this DevOps tools. Under this DevOps, we are using different types of tools here. So actually, we have one pipeline concept here. The pipeline concept, we can call it as a CI/CD pipeline. What exactly the CI/CD? Like if you go with this CI/CD, so we can call it as a continuous integration and continuous deployment. What exactly this? See, within this like a CI/CD process again, so we are going to cover, or we are going to use like three more steps. So the process steps are like this. So in general, the CI/CD pipeline will start with the continuous download. The first one is the CD. So under the CI/CD, the first process or first step is CD, continuous download. See here, let's say coming to the like a development point of view, the development team. Okay, let's say for example, we are having two developers, developer one and developer two. Let's say developer one is working on login page. Developer one is working on login page, and developer two is working on logout page. Example. So once he completes the login page code, where he needs to place the code, he needs to place the code. Okay, he needs to place the code in one storage or one centralized storage location. That is nothing but a repository. or we can call it as a version controlling system. So here, once they complete his code, so they are going to place the code in the repository level. So here, and one more thing, once the login page is completed, again the developer one will start working on some other activity. So by the time, just assume the business team actually they are expecting some changes in login page. So in this scenario, the developer one, okay, they will not touch the existing code which they developed. So what they are going to do, they are going to create one new version, and on this version actually they are going to update the code. They are going to update the code. So here, this is the main version, and V1 is the next version. Okay, in the next version copy, actually here he is updating the code. So here the point is the development process is a continuous process. The developers every time they used to develop the new codes, and they used to like uh, they used to prepare the new code, and they used to update the existing code. So in this scenario, whenever there is a new code is available, the business team is expecting the new build. So that means once the code is completed successfully from the development point of view, they are expecting the same code should be deployed in the next environment. So in this scenario, make sure as a DevOps engineer, we need to download the code continuously from the repository. So here, coming to the repository point of view, we are using different types of repositories. I think people are aware of this. Like we are using different types of like version controlling systems, Git, SVN, PVCS, etc. So here, most of us actually we are using Git as a version controlling system, distributor version controlling system, Git. So once the developer places his code in the Git repository, the very next moment as a DevOps engineer, we need to download that Git from the Git repository to our instance. What is that? We'll discuss. So here under this CI/CD program, the first step is CD, continuous download. From where we need to download the code? We need to download the code from the Git. Okay, we need to download the code from the Git repository. To where? So for this, actually, we are using one more platform that is nothing but continuous integration platform. This is the second step in our CI/CD. Okay, in the CI/CD, in the continuous integration platform. So here we are using Jenkins as a continuous integration tool. So within this continuous integration tool, Jenkins instance, so we used to download the code from the Git repository. And one more thing, coming to this Jenkins, as I said, it is a continuous integration tool. Let's say if you are using a brand new instance, by the time Jenkins is it's a plain platform, okay, brand new. So actually you will not get any plugin over there. So make sure that in real-time program, based on your requirement, you need to download the plugins. So let's say for example, so here I am trying to download the code from the Git repository. So in this scenario, in this Jenkins platform, so I need to download the Git plugin. So here, the make sure as a DevOps engineer, we need to understand what kind of plugins that we need to download, and based on the requirement, you need to make sure that you should have all the plugins in the Jenkins instance. That is very, very important. If you miss any a plugin, so the code will not work. That means we are unable to prepare the build. So that is the reason actually make sure once you start using this Jenkins, make sure that you need to download the appropriate plugins. So here I just downloaded the Git plugin. Just assume we downloaded the Git plugin here. And what is the next step? So as I said, it is a continuous download. Whenever there is a new code, the same code will be downloaded directly into the CI program. That is nothing but a Jenkins environment. So here, based on the tools that we are using, so based on the tools, actually we are preparing the plugins here. So the second next step is, see, it's a code, right? Git is having the, we are placing the code. Developers are placing the code in the Git repository, and make sure that we need to convert that code in the proper format. Let's say, for example, we need to prepare the code in the form of a package. I can say we need to prepare the code in the form of a package. So for that, we are using different types of build tools. Let's say, for example, developer is using like a Java. Okay, to prepare their code, actually they are using Java technology. So in this case, so we need to convert that code in the form of a package, in the form of a file. So for this, we are using the Maven as a build tool. Let's say, for example, developers are using .NET. In this scenario, we are we are using Ant as a build tool. So make sure, as a DevOps engineer, we need to understand what kind of technology that the developers are using to prepare their build. Based on that, you need to install the plugin in our continuous integration platform. So in this step, okay, so here just assume that I came to know that developers are using Java technology. So based on that Java technology, so here in the Jenkins platform, I need to download the Maven plugin. Maven plugin. So here the very simple point is, with the help of the first step, okay, with the help of the first step, we are continuously download the code from the Git repository to the Jenkins server with the help of the Git plugin. And after that, whatever the code is available in the Jenkins instance, we are going to convert that particular code in the form of a package with the help of a appropriate to build tool. That is nothing but Maven or Ant. Okay, so once you while preparing the build, so we used to get the war files and jar files. Okay, so this is the second step. The first one is the continuous download. Second one is the continuous integration. And we all are aware of this. Once we develop the code in general, once we develop the code, make sure that we should check whether that particular code is working fine or not. So our futures are working properly or not. So how we will come to know? So we'll come to know once we apply the unit test cases. Okay, in general format, right? In general process, we used to apply the unit test cases, and then we'll run the test scripts, and based on that, we will come to know. Okay, my code is working fine. But in coming to the DevOps culture, so make sure that we need to automate the testing process as well. Okay, we need to automate the testing process as well. So once the code is deployed from your development environment to the test environment with the help of this Jenkins job, once you deploy the code, once you download the code from the Git repository to the Jenkins mission, and after that, once you prepare the build, so what is the next step? We need to deploy the code into the next environment. But before that, we need to test it whether my application is working fine or not. So for this, so here what we are using the continuous testing method. So here, based on the company strategies, actually we are using different types of testing technologies. Let's say if you go with the Selenium, so for the continuous testing process, we are using the Selenium, and to implement to verify the a code. So what we need to do, we need to gather the test scripts. We need to gather the test scripts from the testing team, and we need to place these test scripts in the package level. Okay, in the build side, Maven or the the dot, and build. So with this, actually we are getting a file. So within the files, actually you need to insert the test scripts, and with the help of the test scripts, okay, whenever you are going to prepare, once you prepare the build, okay, in the, while preparing the build itself, actually the test scripts will be executed, and you will get a what do you call notification. Let's say for example, in real-time program, so once we prepare the build and once we complete the testing strategy testing, and once we apply the test scripts, what we are going to do, we used to send an email to the development team, testing team, as well as the business users if required, business users. So here what we are doing, once we complete these three steps, okay, continuous deliver, continuous integration, as well as continuous testing. Once we complete these three steps, what we are going to do, we are going to send the email notification. That too, the email notification actually we are going to trigger from the Jenkins instance only. See here in all these three steps, okay, we are not going to implement, or we are not going to deploy the code, or we are not going to apply the test scripts manually. Everything is automated here. Everything is automated. So as I said, once the test scripts are completed, everything is fine, then what we are going to do, we are going to send the email notification. Okay, if you receive the if test scripts are completed and the build process is completed successfully, you will get a successful email notification. Otherwise, you will get the failure notification. And based on these notifications, the development team, they will start working on that particular what you call issue. Okay, so these are the three different steps actually which we are following regularly in our real-time program. So these three steps actually in real-time program, we are doing this because at the very first moment, actually developers, once they complete the code, so we cannot say that at the very first step on first time only the entire code will work fine. Okay, so there will be some issues. So the once the a CT, I mean that is continuous testing is completed. Okay, again the development team will start working on the what you call the issue fixing, and after that again the testing team members will prepare the test scripts if required, and after that again they are going to place the code in the Git repository. Once the new code is available, again we are going to pull the code and we are preparing the a Jenkins job, and after that we are applying the test scripts. Okay, these are the three important steps which we are following in our real-time program. Let's say for example, after after completion of this third step, let's say our test scripts are working fine and futures are also fine. So in this scenario, what is the next step? We need to deploy. Still we are in the development environment only. So what is the next step? We need to deploy this code into the next environment. So for this, here the fourth one is continuous deployment. So here, while deploying the code continuously in the next environment, so we are using the different types of configuration management tools. The configuration management tools are here. We are using Ansible, we are using Chef, or we are using Puppet. So most of the companies actually, most of the companies are using Ansible or Chef. Okay, so as I said, once the CT completed, test scripts are working fine, everything is fine. Now we need to what is our next step? We need to deploy this code directly into the next environment. That is nothing but a test environment. So in this scenario also, so we need to automate the script. We need to automate the process. Okay, so for this actually we are using the continuous deployment step. So in this continuous deployment step, we are using the configuration management tools like Ansible, Chef, or Puppet. So here, so if you talk. So let's say, for example, if you want to so if you talk about this Ansible, Chef, or Puppet, so these are all the configuration management tools. So in general, one simple example, if you want to apply the changes on multiple system, more than 5, more than 10, more than 50, like that. So in this scenario, what we are going to do in this a continuous deployment step, we are not going to deploy the changes service server by server. What we are going to do, we are going to make one main system as a controller mission, and other system, remaining system, we are going to consider it as a client systems or the managed nodes. And with the help of this concept, Okay, what we are going to do, we are going to establish a SSH communication between the controller mission as well as the manager nodes. And with the help of this, we can able to deploy the code at a time, okay, from the controller mission to the manager nodes. That is the concept of the configuration management. Terminology is different between like Ansible, Chef, and Puppet. Terminology is different, but the concept is same. So in real time program, so if you want to deploy the service, or if you want to deploy the code on multiple systems, in this scenario, we are not going to deploy the code service server by server manually. What we are going to do, we are going to like apply the communication between the controller mission as well as the client mission, and after that we are going to we are going to deploy the code. So that too, the code will transfer from the controller mission to the client missions only at a time. Okay. So here, as I said, coming to the continuous deployment side. So here we are using the configuration management, either Ansible, Chef, or Puppet. Okay. So we are using playbooks, cookbooks, etc., while preparing this SSH communication and the deployment. So here, once the continuous deployment is done, that means the code is deployed into the next environment. That is nothing but a like a test environment or the stage environment. What is the next step? Again, we need to deploy the same code into the next environment. Okay. In general, in real-time programs, so companies are maintaining different environments in the non-production itself. Let's say they are using the test, they are maintaining the test environment, they are maintaining the stage environment, they are maintaining performance environment like this. Okay, so what we need to do, we need to first of all we need to deploy the code from the development to test, and after that test to stage, after that stage to performance. So based on your requirement, you need to repeat the above steps. Okay, from here you need to repeat the steps from continuous integration. And let's say, just assume if everything is fine, our code is available in all environments which are available under non-production. What is the next step? What next step is, we need to deliver this code into the production. So that is the fifth step. That is nothing but continuous delivery. So here again, with the help of this configuration management tools only, what we are going to do, we are going to deploy the code into the production environment. Okay. So here, as a DevOps engineer, we are not going to implement the steps manually here. So what is the fundamental here? First of all, we need to understand the branching strategy maintained by the development team. Okay, using by the like development team, and based on that, you need to prepare the Jenkins job. You need to prepare the jobs in Jenkins, and based on the technology and based on the tool that the developer is using, based on that you need to download the appropriate plugins. Okay, you need to download like uh, version controlling plugin, you need to download the build plugin, you need to download the test plugins, your configuration plugins, etc. Okay, and also monitoring as well. Okay, so the fundamental thing is you need to prepare your Jenkins instance with all the relevant and required plugins, and after that you need to start building. You need to start preparing the builds with these all five steps. Okay, and also in real-time program, so we are going to do the continuous monitoring as well. So because see, once you deploy your code in that stage or performance or production, so make sure that sometimes actually due to some kind of server related issues, actually sometimes actually builds get failed, and make sure that you should get the proper alerts, and you need to, and with the help of that alert, you should be in a position to troubleshoot the issue. So how can we know all these things means while implementing the configuration? So while implementing the continuous monitoring tools. Okay, people are using Dynatrace, people are using Splunk, people are using what you called Nagios, etc. So like this, actually, we are using different types of continuous monitoring tools. Okay, and along with that, so here during our sessions, we are going to discuss about the containerization tool, that is nothing but a Docker, and also like a deployment tool, that is nothing but a Kubernetes. Okay, right now in the market, okay, most of the companies actually they are using this like a Docker and the Kubernetes effectively. Okay, so before going to there, so actually here if you observe the DevOps process life cycle will be like this. Okay, it is a continuous process. It is a continuous process. Okay, so make sure that as a DevOps engineer, make sure we should be very careful. Like whenever there is a new code is available in the Git repository, and also like in right now in real time program. So the development teams actually they are expecting the builds. Okay, lower environment builds like a daily 2, daily 3, something like that. Okay, twice a like they want to run the like a Jenkins job twice a day. So and one more thing is that as I said, so we need to like deliver the final product, okay, in the production in every 14 days of sprint. Okay, so make sure that this particular life cycle is very very important. We should be very careful while while preparing the build, while deploying the code into the next environment. Usually actually you will get a number of issues, okay, while executing the Jenkins job. Okay, we need to be very careful while writing down the like Jenkins pipeline, at the same time while writing down the configuration management code. That is nothing but, let's say, if you go with Ansible, so here we are using the we are going to write down the playbooks, and while writing down the playbooks, we should be very careful, and we should be like understand the modules, and we should be like what module is that we need as per requirement. We should be very careful while selecting the module itself. Okay, so this is about. And one more thing coming to this. Okay, so as I said, containerization program. So here we are using the Docker as a containerization program. So simple thing, if you go with our virtualization program, our virtualization missions. So in general, if you want to install, okay, if you want to install any application, okay, in your like virtualization missions. So we need to travel n number of layers to reach out our what you call the hardware resources, bare metal. But whereas coming to the Docker, so we no need to like maintain the host or like what you call guest OS. We can install the application on top of the Docker engine itself. Okay, I will give you one simple example. Okay, between the virtualization as well as the like the containerization. If you go with the virtualization, so here if you want to implement any kind of if you want to install the Java application, so what we need to do? So okay, Java. If I want to install the Java, so before installing the Java, so make sure that you need to prepare your guest OS. Okay, on top of the guest OS only, we are going to install this application. Okay, whatever the application that you want, and below of this, like a guest OS, actually we are having one hypervisor. So hypervisor is nothing but it is a software. Okay, it will communicate always. Actually, it will communication. It will maintain the communication between the like a guest OS as well as the host OS. Okay, so guest OS as well as a host OS, and before this host OS, actually we'll have this like a bare metal. Okay, so before this, we are having the bare metal. Okay, so here the point is, if you want to install the Java application, so first of all, what you need to do, you need to travel a number of layers. Okay, you need to travel, you need to cross the guest OS, you need to cross the hypervisor, you need to cross the host OS, and then only we are going to identify, we are going to meet the bare metal. That is nothing but a hardware resource. Simple example, okay, in terms of installation time, if you go with Java installation on the virtualization model, so it will take a minimum 40 minutes or 45 minutes to install Java. But whereas coming to the containerization program, so in on top, using containerization, so you no need to maintain the guest OS. So above on like below this Java application, we are having directly Docker engine. Okay, that means every time actually we are going to install the application directly on the Docker engine. So Docker engine will communicate with the host OS. Docker engine will communicate with the host OS, and then host OS already it is in the sync. It will in sync with the bare metal. Okay, so this is done. So if you take this particular example, the same Java application, if you want to install it on the like a Docker, it will take less than 1 minute. It will take less than 1 minute because the number of layers here, okay, we are using very less compared to the virtualization program. Okay, this is clear. And one more important, so here what we are another program actually which we are going to cover it here is nothing but Kubernetes. So Kubernetes is a like here. See nowadays companies actually they are migrating their application from on-prem to cloud. If you go with Azure or if you go with AWS, make sure that to maintain that to establish a communication between the on-prem system to the cloud, make sure we should have a like a communication channel. So here, with the help of this Kubernetes program, we can able to communicate and we can able to deploy the services from on-prem to cloud. Let's say, for example, if you go with AWS, if I want to deploy the service from on-prem to AWS cloud, so here we are using the EKS. Let's say, for example, if you go with Azure, if I want to deploy the same service from on-prem to cloud, so here we are using AKS, Azure Kubernetes Services. What is the main benefit here? So what we are trying to do, we are trying to establish a communication between these two, the on-prem system as well as the cloud. And with the help of this AKS cluster, we are trying to deploy the service. So that means the entire deployment process will be on AKS or EKS. Okay, AKS or AKS. And like alone Kubernetes also we are using in our regular program. So we are going to create the number nodes. We are creating the pods. We are creating the namespaces to store the like to deploy the services. And to store the services in one particular location, we are using the namespaces, and we are implementing. We are creating some secrets for that for those namespaces. So here ultimately the Kubernetes program will be available, will be useful while deploying the services, whether it is on-prem to on-prem or on-prem to cloud systems. Okay, so this is about. If you have any questions, you can ask me, please. Okay. See, so here I'm getting some questions here. What is the course duration? So here we are covering from the scratch, right? So make sure that we should have some basic knowledge on the Linux program, like Linux commands. Okay, and one more thing, in real-time program, we are using the shell script, or we are using at least one scripting language we should know. So in general, people are using shell scripting. Some people are using like a Python. Okay, so better to have shell script. Okay, as a prerequisite, and we are providing some basic stuff on the Linux program, and we are covering from Linux, and after that we are covering Git, Jenkins, Ansible, Docker, and then Kubernetes. Okay, so we are covering all these tools here. So altogether, actually, it will take 45 hours to complete the entire program. And one more important thing is, so this is not a like a what you call the theoretical sessions actually. So most of our program is on based on the like practical. Okay, like for each and every program, actually we designed some kind of like scenarios, and we used to provide the like here we'll provide the concepts and what will execute the like what you call the commands, or else we are explaining over the like a terminal. Okay, and after that I used to provide some what do you call the scenarios for the practice purpose. Okay, so altogether actually it will take 45 days, okay, 45 hours, okay, to complete the course.